Hey everyone, Mr. M here with you on lesson number 7, the last lesson of the logarithms and exponential unit. We're going to talk about natural logs and E. No, not E, the drug. We're talking E, the irrational number, kind of like pi. No, not pi, like the food pi, the irrational number. Okay, E is an irrational number. It's roughly 2.71828, and it goes on and on forever. If you really want to confuse people, I had a professor at college who would tell people when they said, "What's your favorite number?" he'd say E, and that would really mess with people. So if you want to do the same as my old college doctor would do the same, go for it. It's kind of fun to do. Okay, E, if we have f of x of e to the positive x, that's going to be a continuous growth function. And if we have f of x equals e to the negative x, that's going to be continuous decay. Okay, that's just how e happens to work. And if we have a logarithm that's written with base e, we're going to call that a natural log. So here's an example, right? Log base e of x, we're going to rewrite that as ln of x. I used to think it was like French or something, and I'd say log de naturale. I was actually pretty close. It's Latin. It's a logarithm naturale, so that's why it's ln instead of nl. Okay, a little bit of information there that's kind of useless, but okay. So what we're going to do for these couple of problems, they say write in logarithmic form. And all that we're going to notice is that it's the same thing as before. Our base is going to be the base, but because it's a base e, we're going to rewrite it as ln. So here we have ln, because we switched our base. We're going to switch that 9 in the x position, and that's what we get. ln of 9 equals x. So here's one for you to try. You hopefully pause the video for this, right? We want to change our base, so we have ln here, and we're going to switch the x and the 8. So ln of x equals 8. Then we have writing in exponential form, right? They start off with natural log of 13. We want to write it in exponential. Okay, well, my base here, it tells me is e, even though it's not written there. That tells me. So I have e, that's going to become to the power of x equals 13. Okay, so you have one right here for you to try. Pause the video and resume when you're ready to check. Okay, so ln, that's going to give us a base of e. Our power here is 2x. That's going to be equal to 8. Okay, there's no solving or anything involved. We were just rewriting the form. Down here we have problems that ask us to simplify. Now the properties from lesson 5 of this unit are going to come in handy. So if you haven't memorized those yet and you want to have that graphic organizer out to help you, I would totally suggest it. We notice we have a 5 in front. That means power property. Right? So we have ln of 2 to the 5th minus ln of 4. 2 to the 5th, that's really 32. That minus suggests quotient, which means division. 32 divided by 4. Hey, 32 divided by 4, that actually reduces to 8. So we got natural log of 8. Our second example, 1/2 natural log of 16 plus 2 natural log of 3. Again, right away, these things on the outside, product property. I'm sorry, power property rather. Power. So ln of 16 to the 1/2 plus ln of 3 squared. Now we get product property with that addition that tells us that we need to multiply these things. 16 to the 1/2, that's the square root of 16, so 4. Product tells us to multiply. 3 squared is 9. And let's see, natural log of 36. That's our solution here. So you have one to try on your own. Pause this video and resume when you're ready to check your solution. Alright, let's check it out. We want to use the power property first. So we get ln of 27 to the 1/3. That's kind of like a cube root, so keep that in mind. And ln of 5 squared. Cube root of 27 is 3. And 5 squared is 25. That negative means quotient, so we're just going to rewrite this in fractional form of 3 over 25. If that reduced, we would. Mr. M hates decimals. Don't give it to him. Just leave it in fraction form. Hopefully you got that solution. Alright, we still got a couple other things that we can do with natural logs and e. For example, because natural logs and e are inverses, we can actually use the opposite of what's there to help us solve. What does that all mean? I know that kind of sounded confusing, but let's take a look at an example, right? They want us to solve for x, round to the nearest thousandth, so 3 decimal places. In this equation, right, we have 6 times e to the power of 5x plus 1 equals 13. They gave us e here. So we're going to use its inverse, natural log, at some point to solve. And if you look at the example next to us, they gave us natural log here. So we're going to use e at some point, the inverse, to help us solve. So instead of me just saying all this stuff, why don't we actually do it? We need to get x by itself. First thing that's got to go is this one. We're going to subtract 1 from both sides. We get 6 e to the 5x equals 12. Next thing that's got to go is this 6. So e to the 5x equals 2. Now, at this point, we got to get rid of that e. And we would usually be scrambling thinking of what do we do? What's the opposite of e? Well, we know that. The opposite of e is natural log. So we're going to take the natural log of this side. And whatever we do to this side, we have to do to this side. So here's what it's going to look like. I'm going to take natural log of e to the 5x, and I'm going to make it equal to the natural log of 2. These are inverses, so those just eliminated, and I was left with 5x. On the other side, natural log of 2. I only have one more step. It's divide by 5. Now, not only do common logs show up on your calculator, but if common logs are there, almost guaranteed natural logs will be there with it. So what you're going to do at this point is type in natural log of 2 divided by 5, hit enter, gremlins inside do their thing, and they come out with an answer. I believe here they're telling me 0.139. Okay, it doesn't matter what calculators you're using, Google, your iPhones, whatever, Desmos works well too, or the school calculators. Okay, that's what we get. Let's look at another example. Here we have 8 times natural log of 3x, all minus 58 equals negative 2. First, let's get rid of that 58. We're going to do that by adding it to both sides. So 8 ln of 3x equals 56. If we divide this whole thing by 8, ln of 3x equals 7. Now, again, we're at that point where it's like, okay, how do we get rid of the ln? We're going to use e. This time, though, we're not taking e of both sides. We're actually going to use e as a base, and these are going to become our powers. So it looks like this. E to the ln of 3x equals e to the 7th. That goes back to the first bit of this lesson where I was showing you the exponential growth or decay functions, right? We have e as a base. Now we notice that the e and ln, those are inverses, they cancel. So we get 3x equals e to the 7th, and all we have to do now is divide by 3. Your calculators might not have e to the 7th on there. It'll probably have e to the x. So you're going to want to type in e that, or use that button and then type in 7. Okay, so just be careful of that. And then divide it by 3. If you're using Google, you might have to use the actual E button, like the button on your keyboard, and then the caret button to get the 7 in parentheses around stuff. So just be aware how you type these things in. You really have to be careful. Okay, but if you type it in properly, you get 365.544 as a solution. Got 2 problems down here for you to try. They're both very similar to what was above. So pause the video and resume when you're ready to check your solutions. Alright, let's see how you did. What I want to get rid of first would be this 3. Right? So I'm going to multiply by 3 on both sides. That leaves us with e to the 4x minus 1. 5 times 3, that's 15. We'll add 1 to both sides to get rid of that negative 1. At this point, we need natural log to help. Right? So natural log on both sides. That's going to eliminate the e for me. And we have to divide by 4 to get x by itself. And if you type this all into your calculator, natural log of 16 divided by 4, I believe you should have gotten 0.693. Did you? Hope you did. That's what I got. Alright, the second one you had. First, we're going to get rid of this 3 by subtracting. So 12 ln of 5x equals 24. We have to divide by 12 over here to get rid of it. And then we have to start working with the inverse of ln, which is e. So these are now going to become powers. I know it's kind of a strange thing to do. Don't usually do that too often. But we do it here. That eliminates. We got 5x equals e squared. Divide by 5. You type in e squared divided by 5. And you should be getting 1.478. Did you get that one? I hope so. Someone's got to check my work, right? We're not quite done. We got one more thing, and then we're done. And then we're all done with exponential functions, right? We're all done with the unit after this one little bit. Continuously compounded interest. This is actually something that you should care about. Very similar to compounded interest from before, where it talks about money and bank accounts. This one is when the banks are always continuously adding money in, even on the weekends, even on snow days, whenever. They're just continuously adding money into the account based off of your interest rate. You want those ones. Those ones are really good. Not that the other ones aren't good, but continuously compounded interest is going to give you a lot more money a lot quicker. So here's our formula. A equals PE to the RT. PERT, some people say. I've heard that. Other people get upset when they hear that, though. Anyways, we need to know what each of these things mean, right? A is going to be your amount after some amount of time. P, just like before, is your principal. No, not your school principal, but your starting amount. Okay, just like before. So they're going to tell you, you put so much into an account. R represents your interest rate. And just like the other problems, they're going to give it to you in a percentage. We're going to have to change it so it's not a percentage. Decimal form works best. And T is going to be time, and banks work in years. So we will too. So now that we know what each of these things mean, let's take a look at an example. Okay, it says a CD was started with $18,500 at 3.5% interest. Wow, I don't know where this guy got that money from, but lucky them. Anyways, we want to know how much will be in that account, or how much the account will be worth in 15 years with continuously compounded interest. So we're using A equals PERT here. All right, well, let's see. Principal, our starting amount, lucky person, 18,500. Our interest rate, we said we need to change to decimal form, so we move it over twice, filling in with a 0 placeholder. And then they want to know how long after 15 years. Well, 15 years is our time. So now we can just start filling in. Remember, E is an irrational number. So A equals 18,500 times E to the 0.035 times 15. All right, just plugging in all those values. I would deal with this first, personally, because depending on the type of calculator you have, or if you're good at typing things or not, this is going to be easier to deal with separately. All right, so I've got A equals 18,500 E. When I do 0.35 times 15, it gives us 0.525. This is a little more comfortable to type into a calculator. And if we type all of this all at once, which your school calculators and Desmos and Google can all handle, okay, it's going to tell us that we got 31,273, and it will round up to 49 cents. Think about that for a minute. You put 18.5 thousand into an account, left it there for 15 years, and it almost doubled. Pretty much just sitting there. I wish I could get paid double the amount for sitting around. It'd be great, wouldn't it? Anyways, here's a you try problem. Be aware, there's two questions here. Okay, this first question, which ends here, matches exactly up here. The second one you might have to think about a little bit. So I want you to try it, pause the video, and resume when you're ready to check your solutions. All right, let's check this out. An account starts with 1,200. That's our principal. That's a little more realistic for me anyways. Our interest rate is 2.18%. That's our R value. But we got to change it to decimal form first. So move that decimal over twice, 0 placeholder. And it's saying continuously compounded. So our A equals PERT still works. They say if we keep this account for 6 years, so time here is 6, how much will it be worth? We'll deal with this second question in a minute. Let's deal with this first one. So amount equals 1,200 E to the 0.0218 times 6. That was your initial setup. Again, if you trusted my advice, you would have dealt with this crap up here first, and you would have gotten 0.1308. A little easier to type into a calculator, I think. And if we type in all of this, right, 1200 E to the 0.1308, our calculators tell us 1367.69. Now this is actually a much more realistic outcome. Right? If you buy a CD or something, you're probably going to have that kind of interest rate. 6 years is a long time to not hold on to this money, but not bad what you get out, right? Almost 200 bucks more. The second question here, it's asking how long would it take for the amount to be worth 2,000? So here, how long, that's our t. We don't know t. What they gave us instead was the amount after how long, right? That's our a value. All right, but what about r and p? The interest rate is the same, right? It's the same account. And the amount that we put in to begin with is the same amount. The only thing that changed really was we don't know t, but we do know a. So I'm going to change this a is going to become 2,000. This 1,200, it's still there. My interest rate, it's still the same. What changed is that this is times t. Hey, this is just like the other exponential problems from before. I'm going to get rid of this 1,200 by dividing. And if I reduce, that becomes 5 over 3. We need to take the natural log now to get rid of the e from both sides. Those go away. ln of 5 over 3 equals 0.2. Ooh, I'm sorry, there's a 0 missing. 218t. We've got to divide by 0.0218. And it's going to tell us 23.43 years. So, would you want to really keep your money in there for almost a quarter century just to be worth, 2,000? I don't know if that's the best investment in the world, but if you have that money lying around and they're offering you that kind of interest rate, and why not? I mean, it can't hurt, I guess. But that's it anyways for natural logs and e, and that's actually it for exponential functions unit. So if you have any questions, why don't you bring them to class or leave them in the comments section. I'll answer them to the best of my abilities. See you at Unit 4.